Three basic assumptions of kinetic theory of gases.
Yes, sir.
First was gas consists of large number of extremely small molecules. Second, they are identical rigid sphere. Third, they are in the state of random motion. ठीक है, इतना किया था ना. Now fourth one, write down fourth assumption. If molecules are at random motion, they will collide or they will not collide.
Sir, they'll collide.
If they collide, तो दो टाइप का collision होता है ना, इलास्टिक एंड इनइलास्टिक.
Yes, sir.
इलास्टिक मतलब काइनेटिक एनर्जी इज कंजर्व. काइनेटिक एनर्जी कंजर्व मतलब वेलोसिटी सेम रहेगा ना रिबाउंड होने के बाद.
Yes, sir.
तो ये फोर्थ पॉइंट है. दे कोलाइड with each other and collision is perfectly elastic. They collide with each other and collision is perfectly elastic. Then this also. Suppose this is one cubical container. The gas molecule will collide with the wall of container also. तो इधर से मॉलिक्यूल स्टार्ट हुआ, इससे कोलाइड हुआ दीवार से, फिर से रिबाउंड हुआ बिकॉज इट इज इलास्टिक कोलिजन विद सेम वेलोसिटी. तो वन एंड टू अदर एंड एंड बैक सम डिस्टेंस दे आर कवरिंग. मतलब ये दीवार से टकरा, इधर से स्टार्ट किया, ये दीवार से टकराया और फिर से रिटर्न आया, तो कुछ तो डिस्टेंस कवर किया ना. हेलो हेलो.
Yes, sir.
When a molecule from one wall goes to another, all collides and returns back. So during successive collision, has it covered certain distance? During successive collision, has it covered certain distance?
Yes, sir.
This is called as free path. So the distance covered between successive collisions is called as free path. Distance between covered between successive collisions is called as free path. The distance covered between successive collisions is called as free path. चले क्लियर?
Yes, sir.
ओके, 6th one. देखो सब फ्री पाथ ना सेम टू सेम नहीं होता है, थोड़ा फर्क होता है वो डिस्टेंसेस में. सो वी जनरली फाइंड एवरेज. द एवरेज ऑफ all the free paths is called as mean free path. Wait, 1 second, wait. When do you have your entrance exam? When is your entrance exam?
Sir, is it in the month of May?
Next year,
Yes, sir.
2022 में है ना. So आपने पढ़ाई तो 2020 से स्टार्ट किया और एग्जाम 2022 में है. After what span you are having this exam?
2 years.
2 years, correct. बट जो भी रिजल्ट आएगा वो 3 घंटे का इफेक्ट के आंसर है ना.
Yes, sir.
मतलब इंपैक्ट तो खाली 3 घंटे का है, लेकिन आपने काम 2 घंटे 2 साल तक किया. सो टाइम ऑफ इंपैक्ट, अगर किसी ने रिपीट करने का सोचा मेडिकल एंट्रेंस, तो उसको फिर से 1 साल तैयारी करना पड़ेगा क्या नहीं?
Yes, sir.
मतलब टाइम ऑफ इंपैक्ट इज नेग्लिजिबल एज कंपेयर टू टाइम फॉर सक्सेसिव पोल्यूशन. मतलब फिर से एग्जाम देने के लिए मुझे 1 साल तैयारी करना पड़ेगा, लेकिन एग्जाम तो खाली 3 घंटे का रहेगा. ऑलमोस्ट नेग्लिजिबल. So we can say 7th point, the time of impact, impact मतलब collision का time is negligible. Time of impact is negligible as compared to time taken for successive collision. Time of impact is negligible as compared to time taken for successive collision. तो पॉइंट और देख लो. Number of molecules per unit volume, that is molecular density, is constant. That means suppose this is one room having volume 100. If we have 1000 molecule, इसको जब भी हाफ कर देंगे ना तो हाफ मॉलिक्यूल हो जाएगा. तो उसको बोलते हैं number of molecule per unit volume always remains constant. That is called molecular density is always constant for given gas. If you decrease the volume of the container, in same order number of molecule will decrease. One last point, so that our all assumption regarding kinetic theory of gases completes and we can start with derivation. 9th point, average kinetic energy is directly proportional to its absolute temperature. So when temperature increases, kinetic energy will increase. Temperature decreases, kinetic energy will decrease. Right now this till 9.
Done, sir.
Okay. Those who are having this chapter, ये fixed question है 2 mark का. State any 4 basic assumption of kinetic theory of gases. So first we started with this chapter. Real gas can behave as ideal at low pressure and high temperature. Then basic assumptions of kinetic theory of gases. Now 5 definitions we are doing. First, free path. Same what we wrote in basic assumption, same point I am writing separately as definition of free path. The distance covered between successive collisions is called as free path. Copy first definition.
Done, sir.
Mean free path. The average of large number of free paths is called as mean free path. Right now. Completed?
Yes, sir.
Right. Let lambda 1 comma lambda 2 up to lambda n be n free paths. Thus, mean free path comma lambda bar is lambda 1 plus lambda 2 up to lambda n divided by n, or mean free path is given by this formula 1 upon root 2 pi n d square, where n equals to number of molecule upon volume is called as molecular density. D equals to diameter of each gas molecule. Derivation of this we don't have, only we have to remember formula 1 upon root 2 pi and d square is also called as free path. Write further this much. Okay, third definition, mean velocity. The arithmetic mean of velocities of all the gas molecules is called as mean velocity. Let C1, C2 up to Cn be the velocities of n gas molecules. Therefore, mean velocity, comma, C bar equals to C1 plus C2 up to Cn divided by n. Right? Mean velocity definition. Anmol, which exam you have today? Topic?
So unit test of chemistry.
Okay. Hello, Amay, can you hear?
Hello, yes, sir. Yeah.
Just send your exam timetable if you have got.
So I've already sent.
No, I'm not able to see. That's what I was checking.
Oh, so I'll send again.
Yeah,
Sir.
you told me that day, but I think you might have forgotten.
Okay, I'll send again.
Send, yeah.
Done, sir.
Okay. 4 mean square velocity. Mean means average, but of squares. So the arithmetic mean of squares of velocity of all the gas molecules is called as mean square velocity. Let C1, comma C2 up to Cn be velocities of n gas molecules. Therefore, C square's average will be C1 square plus C2 square up to Cn square divided by n. Write this definition. Okay, done.
Yes, sir.
Next, one more definition. Fifth one, root mean square velocity or RMS velocity. Root mean square velocity or RMS velocity. The square root of mean square velocity is called as RMS velocity. The square root of mean square velocity is called RMS velocity. It's C1, C2 up to Cn, the velocities of n gas molecule. Then C square का average will be C1 square plus C2 square up to Cn square divided by n. Root means square velocity denoted by C is square root of mean square. So it will be square root of C1 square plus C2 square up to Cn square divided by n. Copy till there. In DAV they will ask you one numerical based on this. 4 molecule का velocity दिया रहेगा. They may ask you difference between mean square and RMS velocity.
Yes, sir.
Complete. ओके, ये एक बहुत बड़ा डेरिवेशन है. डिराइव expression for pressure exerted on wall of container. Derive expression for pressure exerted on wall of container by gas. Derive expression for pressure exerted by gas on wall of container or on wall of container by gas. Just draw this diagram.
Written, sir.
Okay. Now see what I have drawn. I have drawn a cubical container whose side is of length L. Don't write it, just listen first. थोड़ा बड़ा derivation है. Consider n molecules of ideal gas to be taken in a cubical container having length of each side as L. Therefore, area of each face A equals to L square, volume of gas comma V equals to L cube. Let M be mass of each gas molecule. Hence, total mass of gas equals to M into N. Density of gas rho is mass upon volume, which is Mn upon Lk. Please copy this much. Only description of container and gas we have given. Yes, done.
Done, sir.
Okay. How many molecules we have taken?
N.
N. That means along each axis, how many molecules will travel? Total there are n molecules. Parallel to each axis, how many molecules will travel?
Uh,
N by 3,
N.
n by 3, n by 3. n तो पूरा है. तो 3 डायमेंशनली इधर n by 3, इधर n by 3, इधर n by 3 एज्यूम कर सकते हैं ना.
Yes, sir.
So let the 3 intersecting edges of cube coincides with OX, OY, OZ axis respectively. As molecular density is constant, hence n by 3 molecules will travel parallel to each axis. Please copy this much. तो 1 मिनट रुक जाओ, हम लोग को प्रेशर ढूंढना है. प्रेशर होता है फोर्स अपॉन एरिया. फोर्स होता है रेट ऑफ चेंज ऑफ मोमेंटम. रेट ऑफ चेंज ऑफ मोमेंटम. एंड मोमेंटम इज मास इनटू वेलोसिटी. इसलिए एक एक पार्टिकल का मास इनटू वेलोसिटी वी आर ट्राइंग टू फाइंड. पहले इधर तक तो करो आप, फिर देखते हैं कैसे निकालेंगे प्रेशर. Finding pressure is actually finding force upon area, and finding force is finding rate of change of momentum. That means we have to always think of momentum. Just copy till this. Yes, completed.
Yes, sir.
So n by 3 molecules are traveling parallel to each axis. Let C1, C2 up to C n by 3 be the velocities of n by 3 molecule. Be the velocities of n by 3 molecules. Consider one such molecule with mass m, having mass m, moving with velocity c1 perpendicular to फेस ए बी सी डी। मतलब वो डायग्राम में आई टुक वन मॉलिक्यूल having mass m, velocity c1 perpendicular to this face a b c d. Can you tell me what will be initial momentum of that molecule? Its mass m into its velocity. Hello?
Yes, sir.
What will be final momentum there? Momentum, collision is elastic. That means it will rebound back, but velocity will not change. So can I say minus mc1?
Yes, sir.
Okay, please copy till this. Yes, done till this.
Yes, sir.
Done now.
Yes,
Okay. So change in momentum will be minus mc1 minus mc1 minus 2 times mc1 by law of conservation of momentum. Change in momentum of wall of container will be plus 2 mc1. What is meaning of this? हाँ, then we'll stop. फिर इसको आगे मैं next lecture में बताऊंगा. What
okay,
is?
sir.
हाँ, एक ही मिनट है सर, because अनमोल का एग्जाम है. अनमोल इसका स्टॉप करता हूँ.
Yes,
See, law of conservation of momentum means initial momentum is equal to final momentum of a system. So initial momentum of gas molecule plus initial momentum of container is final momentum of initial momentum of final momentum of gas plus final momentum of container. तो ये पूरा सिस्टम का चेंज इन मोमेंटम इनिशियल इक्वल टू फाइनल. That means final momentum of gas minus initial momentum of gas, initial of container minus final of container. So minus of final container minus initial container is final gas minus initial gas. So change in momentum of container is minus of change in momentum of gas. Clear? क्यों लिखा है ऐसा माइनस माइनस का प्लस?
yes, understood.
तो आज के लिए इतने. प्लीज कॉपी दिस वन.
Done, sir.
That's all for today. Next class, we'll continue with this. That is on Monday as usual.